Hello, Math 45 students. We are going to start a new section, a new chapter. That chapter is chapter 4. So we're going to go ahead and start on page 1, which is linear functions. So a linear function is a graph whose graph is a line. Linear functions can be written in slope-intercept form. So that's the y equals mx plus b. But because this is a function, we say f of x. So f of x is equal to mx plus b, where m is the slope and b is the y-intercept. So we know that the y-intercept is always going to be that special ordered pair when x is equal to 0, okay? So it says to find a linear equation for the following table. So remember, our goal is to write it in y is equal to mx plus b. And later on, we can change that to f of x is equal to mx plus b, so that our y value is the same as our f of x value. There's really no difference there, other than it's telling us, hey, this is specifically a function, okay? So let's think about what we know. Well, we know that when we have the y-intercept, we have that special ordered pair 0, b, where x is equal to 0, and b is equal to any number. So here we have our x values and our y values. So we have that x is equal to 0. So that represents that b is equal to 3. Perfect. Now I have my m value. So the next thing that I'm going to need is I have my b value. That's what I meant to say. We have my b value. So the only thing that left is going to be finding my m. So remember, my m is your slope, which is your rise over your run. And it's also the constant change between values. So I'm thinking about the constant change. Let's think about our y values here. Well, to get from 3 to 7, you added by 4. To get from 7 to 11, you added by 4. To get from 11 to 15, you added by 4. So what do you predict the next one is going to be? Exactly, 4. So the constant change here is going to be 4. So now I have all of my information. I am going to say that this is equal to f of x is equal to my 4m plus my b value. And remember, my b value, I guess I erased it, was 3. So now I have f of x is equal to 4m plus 3. Now let's go to our second example. So again, we have a 0 for x. So that represents my b value of a -5. Perfect. And remember, your goal is to write it as f of x is equal to mx plus b. So far we have that this is mx plus, and we have our b value as a -5. So really you can rewrite this as f of x is equal to mx minus 5. So the only thing that we're missing here is going to be the slope. So let's see how these values change. From -5 to -4, you add 1. From -4 to -3, you add 1. So hopefully you're starting to see the pattern here, that your y values, your constant change, your m is going to be a +1. So now you have that f of x is equal to 1 x minus 5. Or you can write it as f of x is equal to x minus 5. Both of those represent the same thing. Some students like that coefficient of 1, and some students don't like that coefficient of 1. And either way is correct, okay? Cool. Now, we're going to be looking at our functions that's going to be increasing, decreasing, and constant. And really, the increasing, decreasing, and constant, it all just depends on the slope. So depends on slope. So the first one is saying is that you have an increasing function if your m is positive. You will have a decreasing function if your m is negative. And for your last one, you will have a constant function if your m is exactly equal to 0. So here are some pictures. So increasing, this is my positive slope. My decreasing, that's my negative slope. A constant function, that would be a 0 slope. Okay, so your m is actually equal to 0. So the next example asks you to determine if the following functions are increasing, decreasing, or constant. So in this case, you just want to be focusing on your slope. So here, my slope, m, is equal to a negative 8. Well, since it's negative, it's going to be decreasing. Now here, look at your slope. Remember, it's the thing always in front of the x. So in this case, my m is equal to 4. That's positive, so that's going to be increasing. And for c, f of x is equal to negative 5. Well, if you were to graph that, if I were to have negative 5, that looks like this. It's a straight line. So here, my m is equal to 0. So that means it would be constant. So whenever f of x is equal to 0, that's going to be your constant, okay? So now for slope, we're going to be given our equation. It's the difference in y's divided by the difference of x's, okay? So let's put this into play in a word problem. For example, it says Molly is spending money at a constant rate. So that word, constant rate, they're really saying that this is going to be your slope, which is your m value, okay? And it says, suppose she initially has 1,700, and after 6 months she has 1,130. Find the rate at which Molly's amount of money is changing. So something that might kind of help you is your x values and your y values. So here, your x values are usually going to be your time, because time is independent. No matter what, 1 day is 24 hours, right? No matter what, 7 days is 1 week. So time would be independent. So your x values will always be independent. And y, for the most part, is going to be your money, okay? So let's read this together. It says she initially has $1,700. Well, I know that this money part is going to be a y value. So that's $1,700. Now that key word here, initially. So initially. So if you think about the word initially, think about it in time. If you initially started today, how many days has it been? Well, it's been 0 days. So my time has been 0. So initially, time is equal to 0. Now, for the next one, it says after 6 months. Oh, okay, so this is your time. Time is equal to 6. Now she has money, so that money is 1,130. Okay, so you can think of it as 0, 1,700 as your x1, y1. And you also have 6, 1,130, which would be your x2 and your y2. And so what this is asking me is find the rate at which Molly's amount of money is changing. So what this is asking me is to find slope. So we have to use the slope equation. We know that m is equal to y2 minus y1 over x2 minus x1. So plugging in these values, so I'm going to have my x2, which is going to be my 1,130, minus my 1,700, which is my y1, and then my x2, which is 6, minus my x1, which is 0. I plug that into my calculator and I get a negative 95. So you can say that the rate is decreasing. It's decreasing because it's negative $95 a month. And so that will be your final answer. Now for the next example. It says the population of a city increased from 23,400 to 27,800 between 2008 and 2012. Find the change of population per year if we assume the change was constant from 2008 to 2012. So again, I like to kind of have my XY chart. That just helps me to be organized in what I'm doing. So remember, our X is going to be time. Time is always going to be independent. Now my Y value is going to be population. So I know that population is going to be representing my Y value. So here, the first year that I have is in 2008. So in the year 2008, that would correspond to that population. So 23,400. Now, my next year is 2012, so then that population was 27,800. So now I can rewrite this as ordered pairs. So I have 2008, 23,400 as my X1 and Y1, and I have 2012, 27,800 as my X2 and my Y2. And that slope formula would be M is equal to Y2 minus Y1, X2 minus X1. So what I'm going to plug in for my Y values is at 27,800 minus my other Y value, which is 23,400. Now my X values is 2012 minus my 2008. When I plug this into my calculator, I'll get 1,100. So I can say that my population increased, and it's increased because it's positive value, 1,100 per year. And so that will be my final answer. Okay. Now, in my next example, it says, suppose Ben starts a company in which he incurs a fixed cost of $12.50 per month for the overhead, which includes his office rent. His production costs are $37.50 per item. Write a linear function C where C of X is the cost for X items produced in a given month. So now it's specifically saying that you want a function, and that function you want to call it C of X. So you're saying that you want C of X is equal to mx plus b. And you know that this is right because it wanted a linear function. So any linear function, you can always assume it's mx plus b. So you want to look at our vocabulary here. So if it says fixed cost, well, fixed cost is kind of like your initial amount. That's not going to change. So that's going to be your B value, okay? So that's going to be $12.50. Like no matter what, even if I don't produce anything, I'm going to have to pay $12.50 for rent, okay? So now I know that my B value is going to be $12.50. So fixed cost can be your B value, and also sometimes we refer to it as your initial value. So initial value or fixed cost all represent your B value, which is that $12.50. Now, when I see that $37.50 per item, well, that word per tells me that I'm looking at my rate, which would be the same as my slope. So my M value would be $37.50. So what's really nice about this is that we didn't actually have to calculate anything. We just had to understand our vocabulary. We had to understand what was going to be my b value and what was going to be my m value. So now I'll plug all of these in. So I have that my c of x is equal to my m value, which is that 12. Oops. My m value is 3750 x plus my b value, and my b value is 1250. And so that ends up becoming my final answer. Okay. All right. So let's move on to the next example. So for this one, I have a farmer. A farmer notices that there is a linear relationship between the number of beanstalks N she plants and the yield Y. When she plants 4 stalks, each plant yields 120 ounces of beans. When she plants 9 stalks, each plant yields 220 ounces of beans. Find the equation of the linear function that represents this situation. So the key word here is that you want a linear relationship. So you're like, okay, perfect. So since I want a linear relationship, I'm looking at y is equal to mx plus b. But here they want specific values. It says that n is a number that she plants and the yield is going to be y. So you're going to say that this is going to be y of the value n, which is equal to nx plus b. So they're just switching up the variables on you, but it's the same idea. So I'm going to think about my x and y coordinates here. That's going to help me to determine what I'm supposed to be doing. So it says that she plants 4 stalks, and this is how much it yields. So what I'm going to have is I'm going to have stalks and yields. So 4 stalks yields 120 ounces. The next one is she plants 9 stalks, so that's 9, and it yields 220. So now that I have 4 and 120 as my x1, y1, and I have 9, 220 as my x2 and my y2. So my slope formula, which is y2 minus y1 over x2 minus x1. I'm going to rewrite it. So I have 220 minus 120. My x2 value, 9, minus my x1, which is 4. And when I plug this into my calculator, I am going to get 20. So this is telling me that m is equal to 20. So, or better yet, here, it's really n is equal to 20. That's what they're representing as your slope. So that's this value in here, which is perfect. Now I'm trying to figure out my b value. So let's go ahead and say that. So I'm trying to find b value. So when I find my b value, I can just plug in equations. So remember, I have y is equal to mx plus b. So y is equal to 20x plus b. So I can just plug in one of my x and y values. So why not choose this one? It doesn't matter, you just make a choice, okay? So my y value is 120, and my x value here is going to be 4. So I'm going to have 120 is equal to 80 plus b. So 120 minus 80, and you can do that on a calculator, gives me 40 for my b value. So perfect, now I have all of my pieces of information. Remember, your goal is to write it as y of n is equal to nx plus b. So y of n is equal to your 20 x plus your b value, and your b value here is 40. And so that ends up becoming your final answer. Okay. Now you want to graph. Hopefully you guys remember how to graph. And I'll just go ahead and write some notes over here. So when I have y is equal to mx plus b, remember that b is the y-intercept. So it's really 0, comma, b. That is where you start, okay? So here, my b value is 4. So my y-intercept is going to equal 0, comma, 4. That is going to be the very first step that I take. The next thing that I have is my m. That's going to be my rise over my run. So here, my slope is a negative 1/3. So that means since it's negative, I'm going to go down 1 and to the right 3. I could also go up 1 and left 3. So if I go down 1 and to the right 3, I'm here. I also could have gone up 1 and left 3. And notice how that's still a linear equation. It's still a line. So now when I connect my dots, hopefully it's a straight line. That is what your line is going to look like. If I had a ruler, it would be a lot straighter, but that's okay. Now, it's going the opposite direction for this example. It says, find the equation of a linear function whose graph is given below. So again, they want us to find a linear function. So instead of y is equal to mx plus b, they specifically want f of x is equal to an mx plus b. So what we have to figure out is an m value and a b value here. So remember, our b value is going to represent our y-intercept. Our y-intercept, well, here's y and here's x. Our y-intercept is right there. That ordered pair is going to be 0, -4. So that tells us that the b value is equal to a -4. So the only thing left to find is your slope. Remember, slope is your rise over your run. And this is definitely an increasing graph, so you know it's going to be positive. So let's think about, what do you do to get from here to here? Well, it looks like I went up 2 and over 1. So my rise is 2 and my run is 1. So my m is equal to 2 over 1, which is the same as saying just 2. So now with confidence, I can say that my function is f of x is equal to my 2x, and I have my y-intercept as -4. And that will be my final answer. F of x is equal to 2x minus 4. Okay? And that is the end of section 4.1. If you guys have any questions, please feel free to email me. Thank you.